So let's find the directional derivative of our function at the point in the direction of q, at the point p in the direction of q. We're going to find the directional derivative u. U is not the vector going from p to q in the direction from p to q. It's going to be v, but we can find u, which is the magnitude, not the magnitude, the unit vector, which is the vector v divided by the magnitude. So we'll see that later on. This is just going to be the gradient of our function dot product with the vector u. So that is an important formula that we've used many times in this series. Now the gradient of our function is the composition of all partial derivatives that we can get from this function. So this is going to be the partial derivative with respect to x, y, z, comma the partial derivative with respect to y, x, y, z, comma the partial derivative with respect to z, x, y, z. Remember that we can find f sub x at x, y, and z by treating y and z as a constant. So y squared z to the third, that's what we get. And then f y, x, y, z, treating x and z as a constant, we have x z to the third, 2y. And then f sub z, x, y, z is equal to treating x and y as a constant, we have x, y squared times 3z squared. So we can go ahead and build our gradient now. This is just y squared z cubed comma 2x y z to the third 3x y squared z squared. So now we can go ahead and find it at the point P 311, which is just going to be, let's see, 1, 6, 9. That was an easy one. And then we can find the unit vector by finding the vector v, dividing it by its magnitude. The vector v is the vector going through points P to Q. And so point P is 3, 1, 1. Point Q is 0, negative 5, 7. To find the vector PQ, that's basically just 0 minus 3, which is negative 3. Negative 5 minus 1 is negative 6. And then 7 minus 1 is 6. This vector is equal to the vector v. That's pretty much it. We can find the vector u by taking, of course, this. So this formula, so it's negative 3, negative 6, 6 divided by its magnitude. The magnitude of vector v is the square root of 9 plus 36 plus 36, which is, let's see, 36 times 2 plus 9, it's just 9. Square root of 81 is 9. So this is just 9. This ends up being negative 1/3, negative 2/3, 2/3. And then to find the directional derivative in the direction of the vector u, f of x, y, z, we only just need to take the gradient, which is that 1, 6, 9, dot it with negative 1/3, negative 2/3, 2/3. Gives you 1 times negative 1/3 plus 6 times negative 2/3 plus 9 times 2/3. negative 1/3 minus 12/3 plus 18/3. This is going to be, let's see, minus 13 plus 18, which is 5/3. We didn't really need to simplify here because in the end of the day, we are getting a simplified result. That's your answer.